We often talk a lot about precision and accuracy when we talk about measurements. But what is the difference between precision and accuracy? Or are they one and the same? Let us see. Say we wanted to know the diameter of this cylinder. To know its diameter, you can measure it by using a ruler. Say by using a ruler, I measured its diameter to be 1.6 centimeters. That is up to 2 significant figures. Now when I say its diameter is 1.6 centimeters, I don't mean it is exactly 1.6 centimeters. I mean it is about 1.6 centimeters. That is because this digit in this measurement is an estimated digit. So there is some uncertainty in the value of this digit. And if there is some uncertainty in the value of this digit, what is the amount of uncertainty? Generally, the amount of uncertainty is explicitly stated next to the measurement. And if it is not explicitly stated, like in this case, then there is an implied or assumed uncertainty. And in this case, it is plus or minus 0.1 centimeter. This is based on a thumb rule, and I explained that thumb rule in a previous video. Now, what does this uncertainty tell us? This tells that the true diameter of this cylinder is somewhere between 1.5 centimeters and 1.7 centimeters. Okay, fine. We are able to tell that the diameter of the cylinder is somewhere between these two values. But the more relevant question here is, why do we have this uncertainty in the first place? That is because we do not know the exact value of the last digit in the measurement. Then the question is, why don't we know the exact value of the last digit in a measurement? That is because of some random errors. We discussed about one kind of random error in a previous video, that is related to the least count of the measuring device. So because of some random errors like that, we are unable to know the exact value of the last digit in any measurement, and because of that there is some uncertainty in this measurement, and because of that we are only able to tell the range of values between which the actual value would fall. So my question is, what is responsible for this uncertainty in measurement? It is largely because of random errors. There are many kinds of random errors, and we discussed about one type of random error related to the least count of the measuring device in a previous video. Now let us pause for a moment and ask ourselves a general question. Generally, what do we mean by the word precision? Say you wanted to know the distance between your home and your school, and someone says it is about 2 kilometers, and someone else says it is about 2.2 kilometers. Now, what is the difference between these two values? Generally, we would say that this is more precise or more exact than this. So, if the value has more digits, we mean it is more exact or more precise, and if a value has less number of digits, it is less precise or less exact. So the precision or the exactness of the measurement depends on the number of digits in the measurement. So if you want to know the value of a physical quantity more exactly or more precisely, you need to know the values of more digits in that physical quantity. So if I want to know the diameter of this cylinder more precisely, then I can use a vernier caliper to measure its diameter. Using a vernier caliper, we can measure its diameter up to 3 significant figures. Now I know the values of the first 2 digits with 100% certainty, and now the estimated digit is this. And in this measurement, the amount of uncertainty is plus or minus 0.01 centimeters. So the amount of uncertainty has reduced when compared to a ruler. That means the true diameter of this cylinder is somewhere between 1.57 centimeters and 1.59 centimeters. So we are able to tell the diameter of the cylinder with less uncertainty or with more certainty. That naturally means the exactness of the measurement or the precision of the measurement has increased. And if you wanted to know its diameter even more precisely, you can use a laser interferometer that can measure its diameter up to the 6th decimal place. And in this measurement, the amount of implied uncertainty is plus or minus 0.000001 centimeters. It is very less. That means the range of uncertainty is very small. So now we are able to tell that the diameter of this cylinder is somewhere between 1.592846 centimeters and 1.592848 centimeters. So we are able to tell its diameter with more certainty or with less uncertainty. That means the precision of the measurement is even higher when measured with a laser interferometer. So as we go from this measurement to this measurement, the estimated digit is moving away from the decimal point or moving into a lower place value digit. Because of that, the amount of random error is reducing or the precision of the measurement is increasing. So as the number of significant figures increase, the amount of uncertainty decreases and the precision of the measurement increases. Now what do we observe if we measure the diameter of this cylinder multiple times using the ruler? Do we get the same exact measurement every time? No, you may not, because of random errors. But with a very high degree of confidence, we can tell that all those measurements fall within this range of uncertainty. Actually, that is what we mean by range of uncertainty. And this variation in the values of these measurements is because of random errors that cannot be eliminated. And same is the case with a laser interferometer. If we measure the diameter of this cylinder multiple times, then you may not get the same exact measurement every time, again because of random errors. But with a very high degree of confidence, we can tell that they would all be within this small range of uncertainty. Now, if you look at these two pictures, it is obvious that the spacing between these repeat measurements is very small in case of laser interferometer when compared to a ruler. So that means if the precision of the measuring device is more, then the spacing between repeat measurements of the same physical quantity will be less. And this is what we keep hearing for the definition of precision. An instrument with a higher precision will produce repeat measurements of the same physical quantity that are very close to one another, like this. And if they are not as close, or if their spread is more, that means it is not as precise. And here is what we discussed about precision so far. Precision of a measurement depends on random errors that cannot be eliminated. That is why repeat measurements do not produce the same exact measurement. The variation in the value of repeat measurements is because of random errors that cannot be eliminated. Secondly, a more precise measurement has more significant figures. See, this measurement is obviously more precise than this. Thirdly, an instrument with higher precision will produce repeat measurements that are close to one another because it does a good job at eliminating random errors as much as possible. And that is what we just discussed. And an instrument with higher precision will produce a measurement with more significant figures. See here, this measurement is more precise and it has more significant figures when compared to this. And then the range of uncertainty is the range of values within which repeat measurements of the same physical quantity fall with a very high degree of probability. Or it can also be said as the range of values within which the true value of the physical quantity would lie. And this is what we mean by that range of uncertainty. And that is a small introduction to precision. Now what about accuracy? Let us say we wanted to know the mass of a small steel ball. In your physics or chemistry laboratory, you can measure masses of such small objects by using what is called an analytical balance. And an analytical balance can measure masses up to the 4th decimal place in grams. Say I measured the mass of this ball multiple times using an analytical balance, and these are the various measurements I obtained for the mass of this ball. Now obviously because of random errors I did not get the same exact measurement every time. But these 4 measurements are very close to one another. Each of these measurements has 5 significant figures. So the precision is high. So as far as the precision goes, I am happy with this balance. Then what is the problem with these measurements? They are awfully wrong measurements because the true mass of this ball is somewhere around 9.8726 grams. But look at the measurements we obtained. There is a huge gap between these measurements and the true mass of that ball. Now you may ask, how do you know that this is the true mass of the ball? When I say true mass, I don't mean the exact mass of the ball. I am not saying that I know the mass of the ball up to an infinite number of decimal places with 100% certainty. That's not what I mean. Then what is this value? See, when several people or experts previously measured the mass of this ball using different instruments, they found that its mass is around this value when expressed up to 4 decimal places in grams. So that is what I mean by true value. The accepted value for the mass of the ball is what I am calling the true value. And when I measure the mass of that ball again, I expect to see a measurement that is close to this accepted value. But see what we got. So obviously there is a huge gap between our measurement and the accepted value for the mass of that ball. Now, how do we explain this huge gap between these two values? Do you think it is because of a slight change in the temperature of the room? Or maybe because a little bit of moisture got deposited on the pan as the humidity of the room increased? Or do you think we forgot to shut the doors of the balance before taking the measurement? No, those are not the kinds of reasons we come up with to explain such a huge gap between our measurement and the accepted value. Maybe those are the kinds of reasons that explain these small differences between the values of these four measurements. Those are random errors. Then how do we explain this vast gap between these two values? We obviously suspect that there is something wrong with the instrument or the balance. Or you may think that the operator of the balance is not doing a good job. Only those kinds of reasons can explain such a huge gap between these two values. Now, what do we call errors produced by defects in the instruments? They are called systematic errors, right? And what do we call errors produced by our negligence? They are called human errors or mistakes. Say we are doing a good job, so let us rule out human errors. Then this large gap between these two values must largely be because of systematic errors, right? So the size of the gap between these two values depends on the severity of the systematic error in the instrument. Say instead of this measurement, if we got a measurement like 9.3846 grams, then that measurement is much closer to the accepted value than this measurement that we actually obtained. And how close the measured value is to the accepted value is what we call the accuracy of the measurement. If the measured value is close to the accepted value, then the accuracy of that value is more. If it is far away from the accepted value, then its accuracy is low. And the gap between these two values or the accuracy of the measurement depends on the severity of the systematic error. So, systematic error largely determines the accuracy of the measurement. Random errors determine the precision of the measurements. Now, the important point to be noted here is these four measurements have high precision. They are very close to one another and each of it has up to 5 significant figures. So as far as precision goes, they are all good. But these values are far from the accepted value, so their accuracy is poor. So from this we can understand that high precision need not necessarily mean high accuracy, as we have seen in this example. And that is obvious because precision depends on how well the instrument manages random errors, whereas accuracy depends on how free that instrument is from defects, largely. Therefore, precision and accuracy are two separate ideas and they do not mean the same. And here is what we discussed about accuracy so far. It is the closeness of the measurement to the accepted or the true value. And accuracy is largely a measure of systematic errors. And understand that accuracy and precision are two separate ideas. And by the way, what does significant figures represent? Accuracy or precision? It represents the precision of the measurement, not its accuracy. Now that we understood a little bit about accuracy and precision, the next question is, what is more important, accuracy or precision? I think you can answer that question for yourself. Let us say the accepted or the conventional true value of the mass of a particular iPhone is 135.1278 grams. Now these are the measurements obtained for the mass of the same iPhone when measured by using our defective analytical balance when measured multiple times. Now, by looking at these four measurements, we understand that this analytical balance is very precise because these four values are very close to one another. And each of these measurements has a good number of significant figures. In each of these measurements, the mass is measured up to the fourth decimal place. So, the precision of each of these measurements is good. But all these measurements are very far from the accepted value. That is, their accuracy is low, very low. Now, on the other hand, when the mass of the same iPhone is measured by using a good precision balance, this is the measurement we obtained, 134.52 grams. Now obviously in this measurement the mass is measured only up to the second decimal place. So the precision of this measurement is less than any of these measurements or the true value. But this measurement is close to the true value. So its accuracy is high, though its precision is less when compared to these values or even with the true value. Now I ask you, which of these measurements do you prefer? I would go with this measurement because this measurement is close to the accepted value, so it is more accurate than these measurements. So accuracy takes precedence over precision. You have to first make sure that your measurement is as accurate as possible by eliminating the systematic errors as much as you can. Now, after securing the accuracy of the measurement, you can work on the random errors to increase its precision and thereby get a measurement that is more accurate as well as more precise. But accuracy comes before precision. So in this video, I tried to provide a very brief introduction to precision and accuracy. And in the next video, we shall try to learn figuring out the number of significant figures given a measurement.